Hello and welcome to today's webinar presented by Dlubal Software. The topic for the webinar today is seamless structural analysis utilizing RFEM and Revit structures. My colleague Walter Ressler will be today's presenter. He is the sales director and a customer support engineer in our Germany office. My name is Amy Heilig. I'll be your moderator answering your questions today. I'm the CEO of our U.S. office located in Philadelphia, Pennsylvania. I'm also technical support and sales engineer. Just to let you guys know, when you did log in to go to webinar, the dialog box may get in your way of viewing the slides and the presentation, so you can feel free to show or hide that control panel at any time with that orange arrow up at the top. We certainly want to encourage you to ask questions throughout the webinar. You'll notice that there is a dialog box or a chat option in the dialog box as well that you can go ahead and ask your questions. We'll do our best to get to all of them, but if by chance we don't, I will send you an email afterwards. And with that, I will go ahead and turn it over to Walter.
Thank you, Amy, for your brief introduction words. Hello to everybody. My name is Walter Röstler, and I will show you today all I know about the Revit link. Today we're going to show it with Revit and RFEM, but I want to say at the very beginning the same interface is also available with RStop, which is a lighter version of our FEM software that includes only beam elements, while RFEM has both solid beam surfaces and is the full FEA software. Before we go into a live demo, I would like to give you a brief introduction into this Revit structure Dlubal link. As I said, it's included in RFEM RStop. It's a part of the standard and installation. So once you buy RFEM, you have that interface. It's bidirectional, so you can exchange models from Revit to RFEM and update, or start with RFEM and import the model then into Revit. Not all of the software does this actually. The interface basically refers to all the structure and load objects, so everything that has an analytical member or surface inside Revit that will be transferred to RFEM, including support conditions, end release conditions, typical loading objects, combinations as well. So when you start the interface, you will see a first dialog with general settings where we can set up different options. I'd like to point out that you also can only transfer selected objects or objects that are in a certain view inside Revit. So even so, we're talking about a 3D environment here in our software. You are able to exchange only parts of the structure. Not everything is calculated into 3D models, also we have the opportunity to do that. We'll go through these details during the session also, so most of it you will see also in the live demo. We can make a difference whether we exchange only structural data or whether we apply also the loading. That's important because not everybody does actually do all the loading and the combinations inside Revit. I think as a typical structural software, analysis software, Revit doesn't have all the needed options in their analytical model, so you must have the option to work in your own model as you like, and also we offer the opportunity whatever is already defined in Revit from the analytical objects we can import, and you have some options to choose structural or load data or vice versa. Okay, as I said, we can also import the results, or it is a bidirectional import, and that includes also the result import from the analysis in Dlubal into Revit. So Revit is a more or less a application that serves to collaboration and communication between engineers, and as more information you can have into the Revit database, as better it is for exchanging these informations with other engineers. And for example, we can import now as a new feature, a fairly new feature in the interface, we can import the forces or also reinforcement content that can be used then for further reinforcement drawings in Revit, or also you can look inside Revit at your design forces for let's say connections and other things you like to do inside Revit. We'll share the information. With this said, I would like to go into a live demo of about 3 smaller examples. I'll start with the left one here with a small concrete example. I'll continue with a steel example, and at the end I will start inside Dlubal software and export a example to Revit. The focus is more or less on the features for the data exchange, not so much on the design. Also we will do a small design to kind of feature a realistic design process. Yeah, I'll start with the first example then. I'll now change to Revit, and inside Revit I'll start with the first model. This is version Autodesk Revit 2017. The link is a brand new link that we have to Dlubal, and you find the link actually up here in the menu bar. And when you have installed Revit first and then Dlubal afterwards, you will get this link automatically installed. So the installation will find out that there is a Revit license, and it will automatically install this plugin. If you can't find it, just reinstall RFEM after Revit. Okay, this simple model consists out of a couple of slabs and a few columns. What you see here is the physical model and the analytical model. The analytical model is shown here as the lines, the center lines, and what is typical inside Revit and what is helpful for structural engineers is if you click at one object like this floor here, you have also an analytical instance of this floor, and in this analytical instance you can check different situations. For example, important information is the analytical alignment, and it is now on auto detect, so it will put it on the top level in this case of this floor, but you can also use the projection alignment method, and you can say I want to have it in the center. So you see how this analytical member moves downward, or you can have it on the bottom, or you can reference it to a certain level that you may have defined in this model. But be sure that you set up your analytical model correctly inside Revit. Otherwise, if you don't have this set up correctly, the analytical model is what we actually then import. And if I show only the analytical model, then you will see if the alignment of the columns on the slab here does not match, you might have some trouble with disconnected parts, and in the mechanical analysis this is a problem. So you'll solve these problems already here in the analytical model. So please take some time to set up this analytical model correctly in Revit so we can really use it then. It's important to understand this difference. Okay, in the interface we have here a set of buttons. We'll work with the RFEM buttons. The corresponding RStart buttons are next to here. Also, we have implemented so-called Dlubal parameters where we assign certain properties to objects inside Revit that we can't find in Revit but are helpful for us. For example, we can do a thing like a property that's called without tension for analytical walls. Without tension means that the finite element will fail in case of tension stresses, as we find it typically at masonry walls. If a wall has this property, for example, then it will convert it into a tension only or without tension type slab or not slab wall in RFEM, and we have automatically set this type of surface in RFEM. Same with surface supports. For some situations Revit doesn't offer to enter a support to a slab, so if I assign the surface support there, it will automatically do this. So we have the option to do those parameters. For example, these parameters then will show up here in the analytical objects of this floor, and we can check it here as a surface support, and if I do this I will get some support in RFEM. Okay, let's go into the data exchange. In my background I have an empty RFEM open, there is no model, and I'll transfer the model to RFEM. I export it, I set up my options, I can control the C direction, principal C direction, I create a new structure. I don't need any eccentricities since I have aligned the model correctly in Revit. Yeah, in case of rigid or analytical links that are also possible in Revit, they will be also transformed to rigid or analytical links inside Dlubal. We have also the option to use certain naming for materials and cross sections. So that's also a user-defined parameter. When I click on a column, I can put there an RStart or RFEM cross-section name, and this cross-section name will then be used if this option here is checked, and the correct cross-section will be then set in RFEM. It's also important to know we can export to a file. So let's say you work on a different computer only with Revit and you have no RFEM license there. All you need to do is install a trial version that you can download at our website. Then you can link to this trial version, and in this case it will not require a license, but it will save the Revit exported Revit data to a RFEM file that you can give then to a structural engineer that uses RFEM, and he can open it. So you need no license if you would not have both applications in a full license installed on one computer. Okay, but now we create a new structure. In the structural settings I want to export the structure itself, the loads, and I want to assign the dead load automatically in load case 1, and yeah, also transfer the combinations. In this case we have only a few load cases defined inside Revit, and we'll see that later. Okay, it's all done. We have a small log that you can see here. In case of any problems you will be notified, and we can you can view the log file and you can find what's done and where are problems, where are the IDs, and This is also helpful for support if we need it here on our end. Okay, I go to RFEM, and you can see here the model has been exported, including the grid lines here. And I see also 4 load cases. Loads have been defined or not defined. Here in this case we have a few wind loads already defined, and we can immediately start the calculation, and everything has been transferred correctly, and I have a fully functional model in RFEM. Let me explain you a little bit about the conversion here. We have here different naming of concrete in Revit and in RFEM, and in RFEM we have also codes linked to different materials. That has been converted automatically, as well as the cross sections that are simply named 12 by 18 in RFEM, and we have here rectangle 12 by 18. So by this conversion we make sure we get the right cross sections and the fully compatible cross sections into RFEM. Okay. I'm going to create a few loads here, then we run an analysis, we create some load combinations, the typical work that engineers would do some quick concrete design, and we'll go through some change scenarios. First load case is dead load. I'm going to apply a surface load of 30 PSF in direction C on both of the slabs that I find here. Next I have live load, and live load will be about 50 PSF on the first level, and a little bit less, actually, let's say 30 on the top level. Then we have wind load. Let's say this is good enough, and we have snow load that we need to enter. So another surface load, and I'll stick again with 30 PSF. Note that if you change here the projection direction, you will get an explaining picture here, which makes it really easy when you learn the software. It has a really low learning curve, and it's quite intuitive actually to work with. So I need some combinations. I have only load cases. The data is building up here. We have here now load cases, but no combinations yet. How to do this? Actually, I can automatically create combinations according to a series of standards. We'll choose here AIC 710. There's also Canadian codes, since I know there are some people registered also from Canada today. So this is also possible for Canadian codes. I want to create combination automatically. I click OK, and if I then go into my combo box here for load case combinations, you will see here we have all the combinations for, actually we can explain it here a little bit better, for serviceability and for ultimate limit state. All combinations here are with load factors, and we have a so-called result combination that summarizes as an envelope once the ultimate limit state combination and once the serviceability limit state combinations. One thing I'd like to also do is I want to do a first order or linear analysis. RFEM is capable to do a nonlinear analysis, second order large deformation, post-critical analysis, and includes a series of different solvers that are getting active depending on what type of analysis method you choose. Also, it's possible to do changing stiffnesses from load case to load case. There's many options, and I refer to other webinars that explain those things also. Okay, we run the analysis. I can say calculate all, and while I'm doing this, it's like the real life. I get a call from an architect, hey, there is some changes, we'll need to update your model, and at a time where you think you're in a good way, you have to face, of course, some changes in the model. So I go back to Revit, and inside Revit we'll make a few changes. For example, we delete this column. We don't want it here. We need to do something else. And also here in this first floor we need some opening because we forgot that we have some staircase here, and the staircase needs to have some opening so we can get up into this floor. So some typical changes, and how to get those changes now into RFEM. Well, I just export again the model. This time I update the structure. I don't want to update the loads, so I disable them because I have my loads defined in RFEM. If I update the loads, the software might think, okay, there are no loads in Revit. Maybe you don't want any loads in RFEM as well, so don't forget to switch that off. I start the update. In a few seconds, things are updated, and I have here my openings, and also my column is gone. What's left here is actually the initial line of that column. I can just select it and delete it. I don't need it anymore. It wouldn't have any stiffness effect. It's just left from the definition. Actually, it's quite good because I can see also where this change happened. Okay, knowing this, I have to recalculate, but everything is, that's the important part, everything that I have done in RFEM so far is not lost. I have my work is still there, and also my combinations and everything is there. So I run the analysis again. Let's see if that still works. Model has been updated. If I take a look at the results, okay, you see here there's quite a big deflection, and because that column is gone, I might want to have another beam here. So the engineer has to do some changes too. We create a new cross-section. We'll select a new rectangular section with dimensions 12 by 20 maybe. Okay. Once more, results have to be deleted, of course, and we just snap to the top columns here, and we have this beam entered. Because I want this beam not in the center of the slab, I want to have it below. I define here a so-called rib, and there's a lot of other member types that typically Revit also doesn't have. So there is a reason to have a specific structural analysis software that has all those capabilities, and I enter here these rib definitions, and by doing this, automatically this rib will be placed underneath the surface, underneath the slab here. If the slab thickness changes, it will be automatically also updating the eccentricity. Okay, with this I can calculate all my results again, and then I'll do a quick design of the rebar or the reinforcement I need for those two slabs. And this will be done. What you've seen now is all full RFEM. There is no additional module or anything else needed. And the first design module we're going to look at now is so-called RF concrete surfaces, since we do a surface design. So let me do this quick. Here we choose the ACI 31814 design code. There's other design codes that you can get. For the design, I'm choosing the envelope combination, the result combination 1, that summarizes combination 1 to 11. For the serviceability limit state, I'll include the result combination 2, which has the unfactored load combinations. And I go through my windows here, materials, I have the surfaces, I have my crack width limitations, I have the reinforcement, and I'm not going to do a lot of changes here. I have 2 layers of reinforcement, I have some initial cover that I have set up, I have some longitudinal reinforcement. I could set up some provided basic reinforcement if I wanted to. I have some other options for the code, and I run the analysis. So quite quickly, it's just some initial design, and I get some required reinforcement. Altogether, the summary, I can list it by surface, I can list it by point, and I get also some intermediate results with it, like the resulting forces and so on. Huh? So in the graphic display, it's much more better to understand. We get a new Result Navigator here, and I can show the provided reinforcement for the 2 top directions and for the bottom directions. In this case, I will need something like, you see here the basic reinforcement that we need, that's the red area, and also above the columns I need some more reinforcement. That's quite natural. Okay, so I did my design here, and I have changed my beams, and now I go back into Revit, and I need to update those changes as well in Revit. This way I just import the results. I'll keep everything as it was. I can now apply the loads, so I have also the loads inside Revit if I want to, and I want to import also results. For example, I want to import the forces of the beams or of the columns, and I want to import mainly also the rebars, the rebar content of the 2 slabs. Okay, with this I start the import. In RFEM the results are there and we import them. We're converting all the cross sections, so if there's any changes in the cross sections they will be also updated. We'll see this also in the second example. The changes need to be imported. That means we will have to have the extra beam, and if there are some unsupported combination criteria, it will give a message, but nothing else will happen. And here we have now our imported structure. We see here now we have to change from RFEM. There is this beam. If I go here, edit type, you see it's 12 by 20. It's all there. Then I also imported the results. So how to do this to show the results? Important is to know that if you want to work with results in Revit, you have to install an add-on. You have to install the structural analysis toolkit from Autodesk that you can download in the App Store. And then you get these plugins here where you have the Result Explorer. And with the Result Explorer, we can read those result packages, and any other application that can work with result packages can read also those results. And I'm going to choose here now the reinforcements, and I want to have, for example, the area AYY, and I apply it, and you can see here we get all the content of the reinforcement, including a scale, and this picture can go on any Revit drawing, or anybody who has access to Revit can explore those results. If you want to have the top reinforcement, you import the top, or you display the top or the bottom in the other direction. You can work the same way. Okay, this is the first example with a concrete. Yeah? The next example I'm going to show you is a steel example, and yes, I'm going to close this model here and opening the other model, the steel example. Here we have a few more things in the analytical model I would like to explain. First of all, when we talk about beams, alignment is not quite as simple as maybe with simple concrete structures. So here all the purlins sit on top of the main beams. I chose the top of the main girders as the level, or let's say plane of the analytical model, and I'll put the purlin analytical model on the top of on the bottom of the purlin, so I avoid eccentricities. If you don't do this, you might get rigid links. You might get also offsets that can be converted into we call it eccentricities in our software. It's then getting a little bit more complicated, and in general, engineers tend to the situation that they like to keep it simple. So wherever you don't need eccentricities, we'll keep them out, and so I do here in this case. Okay, in this model we have also almost complete set of loads. Now, if you click here, we have here a live load case. We have different types of different sizes of loads. We have what is it, dead loads and so on. So if you want to, and there are some engineers who work like this, they completely model all the analytical, including loads, in Revit, and update all the analytical things all in Revit, and exchange and send the model to RFEM and do the analysis. In the ideal case, everything is there, and what you can do is you can, okay, maybe first I close my other model here inside RFEM, and I'll keep it closed, and I go back to Revit. I start the interface, and I can export, calculate the model, and import the model right away. So when I do this, same settings as before. Structural setting, let's say self-weight, I apply loads. I want to have also results. This time I want to import the forces. I don't have any surfaces, so I can switch that off. I run the analysis, and RFEM or Revit is creating a new model. We're starting the calculation, so in the background the calculation is already started because it includes also now combinations. So all the information comes directly from Revit, and the automatic sequence is finished, and we imported all the results. And if I go to a view where I have no loads, for example, I just want to import some loads, some results, I can go again to the Analyze menu, Results Explorer, and then we can see here, okay, I want to have, for example, dead load, forces, axial forces, okay, apply, and I have my axial forces here. So 26.12, maybe we have somewhere some units. Yeah, here we are, KIP in this case. Let's see what we have here in our software. So 26.12, and here we have also 26.12. So if you want to, you can just automatically get the results imported in Revit and updated. Yeah? Okay, then of course we don't want to just work with those results here with this simple application, with this simple analysis. I also want to do a little bit steel design here and maybe show you a little bit more what's possible. First of all, when we get this model into RFEM, here for example we have bracings, diagonals, they are now of member type beam, but I would like to have them that they only work as tension elements. So how can I do this? I just go to the visibilities and I choose a visibility where only those cross sections are visible. Then I can easily select them, double click them, and I can enter here tension only, which is also not possible at the moment in Revit, so I have to do it here. Okay, there is a dead load, then there is some live load, and then there is some wind load, and there is no snow load. How to do snow load? First of all, I go to the general data again. I set up here the ASC 710. This time I don't want to have automatic combinations, but because I have already combinations here, they come from Revit, yeah? But I need to enter my snow load. So another tool in RFEM is to generate snow loads from a snow load generator for typical buildings. Yeah? I can go here and I can select from a map where I am, or I can enter here the ground snow load. I can also easily then here pick my outline of the roof. Yeah. When I do this, RFEM recognize all the members which are inside that roof. It also knows automatically from the code, okay, locus 4 is snow. I have no other locus of snow in this case, and I can exclude certain members that I enter here and say, okay, all those members that are parallel to these main beams should be excluded from the calculation of the snow load. Yeah? I click OK. I get a short summary how this snow load was created. Yes, and with this I have a symbol here, and if I want to know what is exactly on each beam, I can right click on it on the load and say please show separately, and I'll see each linear load that is on each purlin, and you can see now only the purlins are loaded and not the main beams, and the loads are transferred from purlin to the main beams. Okay, and the combination can look then like this. Next, I'll do a quick steel sizing. We have AIC codes, and we have also other codes, including the Canadian codes, yeah, CSA, British, and so on. Also, I'm showing here the AIC codes. I want to design all members. I want to have ultimate limit design briefly. Select all load cases, load combinations. I have my materials, my cross sections. They should be all optimized. So I pick the right, please pick the right W shape that we have here in our database. I can set up intermediate lateral restraints which are not modeled, or I can of course set up the effective lengths, and I have other design parameters like reduction of area, so I have a net area for tension elements and so on. I run the analysis. So the design module calculates automatically the combinations that it needs from RFEM. This time we do also a nonlinear analysis because we have tension on the elements, and we can do also second order, of course. We get here utilization ratio, We get here all the cross sections that have been changed here. The changes, the original ones were W1012, now we have a 6x85 and so on. You see all the different colored sections have been updated. You see also design by cross section or by member. You can go through each member and you can check out, okay, where are we? If you want to know maybe this member, what's the design here? We have here yielding, bending about the two axes, lateral torsional buckling, flange buckling, and so on. All the checks are there. If you want to know any detail, you just click here and you get all the intermediate values with the reference to the codes. And basically you can check everything, make sure that the software, or you understand what the software does. Of course, we can also show these results graphically, either with lines, or what is also sometimes helpful here is to show the results members in cross sections. You know, if you want to, you can adjust it here so you get a smoother display. Looks a little bit nicer. Yeah? Okay, I'll have done my analysis. What I have not done is yet I have not re-entered or transferred all the cross sections to RFEM. Results have to be deleted because when I do the sizing, the stiffness changes, and I have to do a recalculation of the results because I have changing stiffnesses. We don't do automatic recalculation because if you have larger models, then it may take a longer time and you cannot really work with the design. But in this case here, we have it all basically then updated. So my preliminary design is done. What I have to do now is I have to update my Revit model. Please note that we have like eccentric beams that lay on top of the purlins. I go here and I say, okay, Dlubal, import model. I'll maybe want to have also the results again. Updating existing structure. Everything is there. I want to have my loads. I'm importing all the new cross sections. They are converted. The conversion takes some time because there can be many families that are loaded inside Revit, and we have to go through every member. Then we are updating the members, writing into Revit, reading the internal forces, and everything seems to be okay. So everything again, the alignment, justification of the beams has not been changed. Yeah? We still have the eccentric level here. I only update the cross sections. If you do undo, redo, you can see, hang on, you can see how the sections are changing. Yeah? Okay, and we also want to see maybe the results. Let me see, where are those? I'm going to show here analytical loads, results, analyze, result explorer. Here we have the different results. We have here timing. Yeah? 833, 43, here we go. And at the same way we can here import now also our axial forces and display them as shown before. These pictures can then also go to a plan, yeah, to a sheet. For example, in Revit I have created something like this. I have my 3D view, maybe like this, and I have different side views that I can show. Yeah. And if I have a sheet, I can just drag and drop those views here, and you have an ideal tool how to document your calculations. Also, I can get here maybe my results, and maybe another view here. I don't know, as you like. You can arrange it on your sheet here. So, this just gives you additional options how to work with our software. It's all integrated. It seamlessly integrates into this BIM environment. Maybe a few more other things, what's possible in RFEM. Not only Revit has a modeler, RFEM has also very strong capabilities in changing and modifying models. I can, for example, just drag and drop here another bay here. I can go ahead and, for example, just select Control C, Control V, copy paste with a certain offset here my beams. I can delete this. So every change you do, you can, as seen before, you can just update your model inside Revit as well. Okay, results doesn't make any sense now because I have not calculated them new and I did not adjust my loading. But yes, I can import everything and it will be updated the same way as seen before. Okay, and the advantage, of course, is then also if you have all those updates with your drawings and everything, you have that all also automatically inside your documents. Everything is intelligent. If I go to my overview here, things are updated as well. Yeah, and you don't have to start from scratch. Okay, I'm going to do one more project. I'm using a new model here, empty model here inside Revit. I'm going to open a building that I have done here in Revit, in RFEM. It has also all kinds of loads and seismic loads and so on. So it's quite a little bit more complex model, but I want to demonstrate that I also can import such models here into Revit. Dlubal, import model. This time I have to do this, just a structure. Okay, start. Because I have more than one model open in RFEM, I'll be asked which one I want to have. So I choose the concrete building. I'm writing the surfaces. You can actually see what happens. I don't have to even talk about it. Openings. Okay. Okay, there are some warnings that we don't really have to look at the moment. And I can go to a 3D view, maybe show not the analytical, but the full model. And you can see you have also here a new model inside Revit that you can use for communication. You can just read what kind of materials are there, what kind of depth are there, what do we have here. It's just you have your model in your own environment and you don't have to ask or go through plans and sheets of paper, printed paper, you have just a much better understanding how that building looks alike. Okay, with this, I think I am almost done with my presentation. Maybe I want to summarize. We can do several scenarios. One scenario can be that we can export the analytical model, and in this case the entire model, from Revit to RFEM or STOP. We'll can add and modify the supports, releases, loads, make our design and optimize the structure there, and then I'm done with my structural design. I don't have to update. If I want to, I can update to an existing or to a new file, and you can update the cross-section changes, the thicknesses of walls and slab, new objects, removed objects, and you can also optional have an update of loads. So that's one scenario. The other scenario is like a smaller version of the one that I described. You just export a part of the model, so you can go slab by slab, column by column, frame by frame, whatever you want to have. You just select it, or you create a view in Revit, and you will be able to export only a portion of the complete structure. And the third scenario is you have a model in Dlubal software, in RFEM or STOP, and you transfer that into Revit to do their drawings, to find out what quantities you have, to just collaborate with some other engineers that work based on Revit or based on Autodesk. With this said, I'm at the end of my presentation, and maybe we have time for a few questions. There was one question that I can see here, which is about the Revit 2017 interface that is not in the earlier versions. In which version is that interface? Best thing is you go to our homepage, dlubal.com, choose whatever language you prefer, download and info, and here you can download our trial version. If you have a service contract, you can also log in with your email and your password here in your account, and you should have gotten actually an email about the new version. But if you don't have yet, you need to download the latest version here. You can use as well the trial version. It will run for a while, or you have a license and you will transfer to a full version. The version that is required is the version 06/30/39 that just came out last week, and it includes that Revit 2017 interface. If you want to work with results, don't forget to install the structural analysis toolkit that you can receive from Autodesk. Another question is about IFC support. Maybe I have to lose a word about IFC also. There's some new feature in this version 506/30/39. This is only in RFEM. We have implemented something that's called CAD BIM model. You find it under options, and you have to enable this CAD BIM model here. I created a new model now, an empty model. And inside this CAD BIM model, if that's enabled, you have a fourth navigation navigator here, and in here you can import IFC, or if you have RFLink, STEP and IGES files. And this difference of this IFC import is that it uses the coordination view 2.0. We are certified as a IFC compatible software for import of coordination view version 2.0 IFC files. which is basically plain geometry. I have one file here that we can use. It's a physical model that I can display inside our Revit, or sorry, RFEM. I should have changed the Z-axis upward. But you see all these features here, all these objects here that are in the IFC file. But now we can't calculate it because it's only geometry. We don't even know, for example, what type of material it is, or whether it is even a slab. So we use the geometry information that, and if you click on here, you see all the IFC files and elements, slab, and so on. Yeah? So if you want then to convert it into a native Dlubal file, we can right-click on it, create surface, for example. I have the option to set up the alignment, top, centric, or bottom. If I have information what it is, it will read this information. I want to have a surface now. I can create also solids if possible, if I want to. Yeah. Okay, and then I can have my surface already here. I can grab this and I can work with this. I can hide the rest of the model, and I have my geometry here that I can work with just as a regular RFEM model. So I also can read multiple IFC files. So this is a good thing, a good addition for BIM users. I want to point out also in this context that there is a variety of other import formats. And if you are wondering why I pointed out this coordination view, we have also a second view, IFC type view, which is the so-called structural analysis view that allows to read also data like support conditions, loadings, releases. It's actually written in the way that the structural analysis software would expect the data to be written. And if you have a structural analysis view file, it's ideal for us because I can just read it and right away calculate it if it's set up correctly. If I have only a coordination view file, and then I have to transfer this physical model into an analytical model first with all the topics like eccentricities, non-connectivities, and all those things. And for this is this new BIMCAD model a great tool. Yeah? Since we are here also in the detail setting, you can set up the conversion files, mapping files for your cross sections and your materials. For example, I have set up anything, for example, in Revit, concrete is called like this, for example, and I want it to be transferred automatically into our material from our library. I can pick here from my library, and I go right away to the right settings, and I have all my correct material properties that I otherwise don't know if they are correct in Revit or if they are correctly set up. So this is where you find this. This is one alternative, or you can use this parametric, this Revit parameter that I've been talking earlier about it. But this is the most common way how to match and map materials and cross sections. Another question was about stiffness reduction. It's actually not a BIM question, but more like a question of design. Maybe I go back to the steel model. We have implemented this stiffness reduction. So if you edit a member, you can go to modify stiffness, and here you have two different codes, AISC and ACI. If I check AISC, for example, it's this tau beta iteration reduction that we can do here. You can do it iterative, automatically, or by LRFD or by AST, or you can set it to 1, and then you can work also with notional loads that we call here in our case imperfections. So we have done those new things here for especially the US market, and other changes will follow. Yeah? So this is maybe something to that answer, to that question. Okay, that is what I have seen that I can answer quickly, and was maybe interesting for all of you guys. Having said this, I'm going to the next slide, and I'll ask Amy if she's able to take over again and to say the final words.
Perfect. Thank you, Walter. Just to let you guys know, we, of course, have quite a bit more information on our website on all of our products, who we are as a company. Probably answer a lot of other questions you might have at dlubal.com. We have a lot of other social media sites, especially our YouTube site, a lot of recorded webinars that we presented earlier, such as today. So that may be helpful if you guys want to go ahead and visit that there as well. Our email at our Philadelphia office is info-us@dlubal.com, and the phone number is 267-702-2815. So you guys can feel free to reach out to this office, a little bit closer in proximity than Germany. So go ahead and use those email and phone numbers. We'll have more webinars coming up next month. You can register at dlubal.com under support and learning, and then webinars. You'll see the links to those. I'll, of course, send out more email reminders as you guys have previously been receiving. You'll notice that on the right there we have a webinar on June 23rd set up already. It will be modeling and design of piping systems in RFEM using our new add-on module, RF piping. If you guys are interested in PDH credit today, which I'm sure some of you are, just go ahead and request that at info-us@dlubal.com, and I will be happy to email that to you. And with that said, that concludes today's webinar, and we certainly hope to see you guys at the next one. Thank you.